Hi guys, and welcome to my video on tangents and normals, part of the Year 11 Mathematical Methods VCE Units 1 and 2 course. And breathe. Now, yes, that's here in Australia, but believe it or not, because maths is a constant, I know, tangents and normals are everywhere. Now, my name is Darren from Maths Guru. Hopefully this video is going to be really important. If you want to, head over to mathsguru.com. Yes, that impossible to spell word. And sign up for free, where you can get these videos, downloadable lesson notes, VCAR exam questions, and so much more. As you can see behind me are my learning objectives. What are we going to do? Know how to find the equation of a tangent to a point of a curve. Hold on a moment, haven't we already been doing that? Not quite. Know how to find the equation of the normal to a point of a curve and use the CAS effectively to find the tangents and normals. And the whole point here is you've got a CAS. This is a CAS-enabled course, and even if it's not, you can do it by hand, particularly in parts of the world where you don't have a calculator that does this all for you. There are steps you can follow to mimic and get this right every single time. Now, basically, this is a new section of work for mathematical methods, and it's where stuff gets really interesting, because a lot of the work we've done before is theory-based, all right? How to differentiate, why are we differentiating, what are the rules of differentiation, what are limits, yeah. Now we start getting to points where we can apply that. We get some more complicated questions where we're asked to sketch graphs. Now, if we go back to the idea of what we've been able to do before, if I draw a set of axes, really bad axes, and I drew a quadratic, that's okay. We have tools in our tool chest now to be able to help us find our crossing points here, to be able to find our minimum, our lines of symmetry. We can find out all sorts of stuff. If we've got any type of polynomial, we can find the linear factors or quadratic factors, depending on what type of function it is. There's a lot. And those are all tools that we've got to start using. But we then got to the idea of, basic cubics. And I'm going to say something like this. All right. And again, yes, we've got the tools to help us now find this by factorizing. But what we haven't got is a way of finding where that maximum and that minimum point actually are. Right? And that's the sort of exciting stuff that's going to come up a little bit later on, because you might turn around and say, well, it's going to be symmetrical. It actually isn't. So we need more tools to help us be able to do this. But let's not run before we can walk. Now I'm going to recap the idea of an equation of a straight line. You've been doing this since year 9 if you're here in Australia, and yes, you've got the idea of y equals mx plus c. You've probably had that drummed into you like crazy. What does the m stand for? It stands for the gradient. What does c stand for? It stands for the y-axis intercept. We know that. We got a little bit more complicated in year 10, where we said, well, actually, we can think of the equation of a straight line as that. Y minus y1 equals mx minus x1. All right, now in that situation, we've got to start realizing, well, when would I use that? In this situation here, maybe I've got my gradient and I've got my point and I'm trying to find my intercept. Yeah? I always find that a bit complicated. I much prefer this because, again, this makes the algebra a lot easier. Why? Because we've got an x1 and a y1, or a y1 and an x1, which is just one coordinate, and m is the gradient at that coordinate, right? So again, we're going to be very careful here. This value of m is the gradient at this coordinate. Now, when we're dealing with straight lines, that's fine, because the gradient is the same all the way along the straight line. Where do we get our value of m from? Well, this, y2 minus y1. All divided by x2 minus x1. And you're going to go, huh? And I'm going to say that's nothing more than rise over run. So if I write that as rise over run, all we're saying is here, y2 minus y1 is a change in height, x2 minus x1 is change in width or length, or, along the x-axis or what have you, right? Now, this is all well and good, but how does this apply to what we're getting to? Well, when we differentiate, what are we doing? Hopefully by now you've got the mantra as we're finding the gradient of the tangent at a point. Okay, hold on a moment. We are finding the gradient of a tangent to a point, or at a point. So there, we've got a gradient and we got an x1 and a y1. Oh, hold on a moment. Well, that's really the crux of this lesson, if I'm being honest with you now, because if we've got a gradient at a particular point, then we can find the equation of that tangent. And again, just let's remember what we're doing here is, here's my value. Let's say that's my graph there. what I'm going to do is I'm going to put a point here. If I'm going to draw a tangent to that, a tangent is nothing more than a straight line. And all straight lines can have an equation, and an equation of that straight line needs only two pieces of information. And that is, well, it's probably, I'm just thinking about that. Let's say it's only two. I need to know the gradient, and I need to know the coordinate of that point. So that's really what this lesson is going to be all about. So let's find the equation of the tangent. And a lot of people sort of, when they read these questions in exams, get very confused because they're like, oh, the minute you see the word tangent or equation of a tangent, the first thing you're going to do is find the gradient at a particular point. How do you find the gradient at a particular point? You differentiate. So let me see what I've got here. I've got y is equal to x cubed plus a half x squared. Right, okay, so the first thing I'm going to do, step number one if you want, is I'm going to differentiate. So I'm going to say y dashed is equal to 3x squared plus, well, that 2 is going to multiply by the half and give me just 1. So that's just going to give me 3x squared plus 1. So that's my gradient function. And it's really important to realize that that there is just a way of finding the gradient at any point on that graph, so long as I've got my value of x. Okay, so let's change because that orange is a horrible color. Right, so what have we got? We need a point. Well, we've been given a point. We've been given a point that x equals 1. So I can now find my gradient at x equals 1. Now, I'm not writing these down the side for me to overlay, but I write it because there's a process in my head. And so long as I follow that process, I'm going to get this right pretty much every single time. So I'm going to find my gradient at x equals 1. So therefore, my gradient, so I'm going to write it as m now because y dashed and m, same, is going to give 3 times 1 squared is 3, plus 1, which is going to give me 4. So I've now got my gradient. Now remember, we're heading towards the idea of using y minus y1 equals mx minus x1. What have we so far found? Well, I've now got my value of m. Okay, the y and the x are static. We don't need to worry about those. They are just there to help us get my equation as y equals da 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 da. So I've got to find a y1 and an x1. Well, that's just the point on the line. But they've not given you a point on the line. Of course they have. Because again, what they've tried to do, and it's such a standard trick, is they've told you where x equals 1. Well, remember, for my gradient, I only really need an x value. But wherever there isn't an x value, I can work out a y value by using the original equation. And sadly, a lot of people then go wrong here because they put this x value into here and they get 4 again. And they think that the y coordinate is 4. It isn't. You got to make sure that you put that value into there. So let's see what happens now. So when x equals 1, we've got y is equal to 1 cubed plus a half of 1 squared. Well, 1 cubed is 1. 1 squared is 1. That's a half. So that gives you 3 on 2. So now I've got all the information I need because I've got my coordinate value as 1, 3 on 2. So there's my x value, my y value, or my x1 and y1. So let's substitute it into here. We get y, he says, y minus 3 on 2 equals m, which is 4 lots of x minus x1, which is that. All right, I'm going to multiply everything by 2 for a moment. And again, I have a particular way of working. I don't like fractions. I'm going to multiply everything by 2. And again, depending on how good your algebra is, you might want to multiply out the brackets first, but I don't. So I'm going to say that as 2y minus 3 equals 8x minus 1. So we get 2y minus 3 is 8x minus 8. 2y is equal to 8x plus 3 to both sides is going to be minus 5, and then divide everything by 2 gives me 4x minus 5 on 2. And there we go. We got my equation of my tangent at that point. Now again, there are lots of ways algebraically of doing this. Don't let me railroad you into it. If you wanted to multiply that out first, not a problem. It should work. You're just going to end up with fractions. And if I'm honest with you, I don't like fractions in any way, shape or form, because if anyone's going to lose a mark, that's where they're going to lose them. Now, CAS calculators, they're brilliant, aren't they? They're here to try and make life a lot simpler for us. So let's fire up my CAS. All right, so starting with my TI Inspire, how on earth do we find, well, as I say here, there is a great function called, oh no, I didn't circle the right thing, tangent line. So what I'm going to do is go to a calculate screen. I'm going to go menu, algebra, is this the right one? No, calculus, and then tangent line. There we go. Oh, interesting. We've got a normal line there. I'm coming up to that. So there's tangent line. Now, realistically speaking, that's really, really annoying because I don't know what I've got to put in the brackets. And if you're ever not sure what to put, if you hit the book and then go and we'll find PQ, I'd be all right if I know my alphabet as well. RS. Come on. Cool. All that clicking of that mouse. Sorry. There we go. Tangent line. Now, if you click on that, it says expression, variable, value. All right, so what they're saying is here, put in your expression. That's not y equals, that's just your expression. So in that situation, it would be this x cubed plus a half x squared. Your variable, basically it wants to know, well, what variable are you using in there? X, you'd think the calculator would know that, but it's a dumb piece of machinery. And then the value, and it's basically the value at which you want to find the tangent line. Again, this is the x value. So let's have a play and see what we can do. All right, so we said here we're going to put in my equation. So x cubed plus a half of x squared, comma x, comma, and then 1. Hit enter, and lo and behold, was that not easy? Absolutely. 4x minus 5 on 2, which was our right answer for the TI Inspire. Now, this is a CAS course, and in the paper that you have multiple choice and extended response, of course, you'd be wanting to use as much of your calculator as you possibly can. And your teacher, hopefully, throughout the course of this year, will teach you all those individual sort of shortcuts and tips, because life is going to become much, much easier if you can do it on a calculator than having to do it by hand. But if you're on the short answer paper, obviously you don't have a calculator, and so you still need to know how to do it by hand. All right, don't get tricked. Right, that's that one. Let's see if we can bring up the class pad. All right, the class pad says go to menu, main. So we're going to go to main, he says. Oh, hitting the wrong thing. I always do that, guys. I'm sitting here like a muppet trying to work out how to, why my computer's not working properly, and it's because I'm clicking the image rather than, so we can click on main. What does it say next? It says to go to interactive. It says go to calculation. It goes to line. And then tan line. Wow! And then again, it's pretty much the same sort of notation as before. The expression is going to be x cubed plus a half. This is going to be interesting. I'm going to put that in brackets. A half of x squared. And then I'm going to go down here and 0.1. Hit enter. And again, out comes 4x minus 5 on 2. Don't worry about all the rest of the stuff that was here, guys. That was just me working on stuff for a previous lesson. So being able to use your calculator, hugely, hugely important. Let's switch them off and move on. Now, equations of normals used to be massive in this course, to be perfectly honest with you, but not so much anymore. But it's important to be able to say that when you can find the equation of a tangent, you should also be able to find the equation of a normal, right? So a quick sketch actually makes this a bit easier. So let's assume that's my graph, or a subset of my graph of y equals x squared. Let's say that there is my point where x equals 1. So we would now know that that would be 1, 1 if I had my coordinate value. Now, the tangent, we now know, let's choose a better color to draw it. Now, let's do it in black. There is a tangent to that point. Yes, a tangent just touches it, theoretically even distances either side, but let's call that my tangent. We can find the equation of that tangent. Now, a normal basically is the line that passes through the same point, but at 90 degrees. So with any luck, this is going to let me move it over. So I can actually put it through that point. There we go. So that there could be a normal. And it's so important to realize that between the tangent and the normal, there is 90 degrees. Okay. They share the same point. So we now know we have a coordinate that actually we can use to find the equation of the normal. And you're going to turn around and say, well, okay, but where people get tricked is they think that basically we can then use the same C value. And I want you to imagine that this here now is my, what would that be, my y-axis. I know that's a really bad idea because it's not going to work perfectly, but what you need to realize is that the intercept for my normal is going to be very different from the intercept from my tangent. So you have to go through and do all the working out. But there's a great thing here, because there is a rule that if we know the gradient of my tangent, I can find the gradient of my normal really, really easily. Now, the official formula says that the gradient of a tangent multiplied by the gradient of its normal would be -1. Okay. Alternatively, we can then say, well, okay, the gradient of the normal is the reciprocal of the gradient of the tangent, but negated. Now, again, does that make sense? Hopefully it does, because if this here has a positive gradient, this here would have to have a negative gradient. And I've seen exam questions in end of year exams and in fact VCAR exams in year 12 that get you to realize or hope you understand the idea that if that's a positive gradient, that would have to be a negative gradient and vice versa. Now that minus sign doesn't just mean, oh, it's going to make it a minus gradient. If this was what we started with, they might give you the gradient of the tangent, of the normal. You'd be able to find the gradient just by negating it. This is the way I was taught it at school. You take the gradient of the tangent, you flip it upside down, and you reverse the sign. Job done. All right, so take the gradient of the tangent, reciprocate it, flip it upside down, and change the sign. That's effectively what that means there. Right, okay, so let's see. Find the equation of the normal to the curve with equation that. Now, you've got to realize here that to be able to find the equation of the normal, you have to find the gradient of the tangent first. So let's think about this in another way. Well, good news here. They've actually given me the point. -1, 1 minus 1. So I don't have to worry about, they haven't just given me x equals 1, they've told me. And you'd always be best to check that actually, is that true if that goes into there? If I put 1 into here, will I get -1 out? Yes, I will. Right, so we've got to find firstly, the differential. So we're going to find y dashed, which is basically going to be the gradient at a point. It's going to be 3x squared minus 4x. There we go. Why do we find the gradient? Because we want to find the value of the gradient, because we're using y minus y1 equals mx minus x1. Okay, so now we're going to find my gradient at x equals 1. And again, they do this to try and trick you, because a lot of people will put -1 in there because they'll get confused. They'll be like, oh, I got -1. Don't put -1 in. So we get my gradient is equal to 3 times 1 squared, which is 3, minus 4 times 1, which is 4. So my gradient there is going to be -1. Now that's my gradient of my tangent. So I'm going to now write the gradient of my tangent is equal to -1. The gradient of my normal is going to be, reciprocate it. Well, 1 on 1 is 1. And reverse the sign, a negative becomes a positive. So the gradient of my normal is going to be 1. Okay, cool. So I've now got my m. Do I have an x1 and a y1? Yes, because as I said here a moment ago, the gradient of a tangent, or the tangent, sorry, and its normal will pass through the same point. So I can use the same point here. So I now know I've got y minus y1, which is -1, is equal to the gradient of my normal, which is 1, times x minus x1, which is 1. So you got y plus 1 is equal to x minus 1. So y becomes equal to x minus 2. And lo and behold, you're a genius. And those type of questions come up all the time. And it is so formulaic. I've even written the example here with what you try to do. Okay, so as I say here, the first stage I always do is to differentiate the function. Then I find the gradient of the tangent at the given point. I would find the gradient of the normal by basically reciprocating and reversing the sign, and then using y minus y1 equals mx minus x1. Now, I'm just going to pause for a moment because someone's got something to say. I know this is a really good bit, but can you do me a massive favor? Click that little subscribe button for YouTube. It really does mean the world to me. If I get 3 subscribers by the end of the day, I'm running around my house like a lunatic. The dog thinks I've gone mad, but it's really the only way I know that people are watching my content, other than my mother, who phones me every night. But that's too much information. Clicking the subscribe means the world to me. If you could do that, that would be great. And spread the word. Enough of me? I think so too. Back to the guy over there. Let's move on to, can we use the CAS for this? Oh, of course we can use the CAS in a short way. I sort of told you earlier, because if I bring up my CAS on my screen, if we go menu, calculus, and then here, normal line, and exactly the same thing. If you're not sure of the notation, you can hit that little book thing, but in this situation, it's x cubed minus 2 up minus 2x squared, comma x equals 1. Hit that, we get x minus 2. And you're going to say to me, how does that work on the class pad? What do you mean, how does it work on the class pad? Let's see if I can bring up my class pad. There we go. So fingers crossed we go interactive. What would I do? Calculation, line, and then normal. And lo and behold, let's just check that this works. X cubed minus 2x squared. Variable is that. Put in 1, hit enter, he said, and out comes. Oh, now you're going to turn around and say, what happened there? Well, that's because I don't know how to use the calculator properly. And it would appear that I have put that in the wrong place. I've actually asked the calculator to multiply it, but there we go. Whew. Luckily, I know what I'm talking about. Lucky I know what I'm talking about. So here are my learning objectives revisited. Did we know how to find the equation of the tangent to a point? Yes. The equation of the normal to a point? Yes. To use the CAS effectively? Yes. I think we're done. So thanks very much for watching. If you can subscribe, that would mean the world to me. Tell your teachers if you found this resource useful. But otherwise, hopefully I'll see you in another video. If not, head over to mathsguru.com. All this stuff is downloadable. And hopefully I'll see you again. Take care. Bye-bye.